Hello students, let's see this question. This is a very good question. So first of all, we make a frame of this question in our mind. Okay, so let's start a break which already have been prepared. So an organic compound A, this is organic compound. This reacts with the alcohol and to form the ester and acid D. Okay. When this ester will be hydrolyzed, then acid will formed and the alcohol will formed. Obvious सी बात है, ester hydrolysis of ester gives alcohol and acid. And this alcohol again when oxidizes, then same acid will obtained. Okay. And this alcohol give positive test with I2H minus. So this means this is the iodoform test. So here alcohol. So this means this is 2-degree alcohol is present. Now acid D, when this will react with the calcium hydroxide, so this will compound and also heat, then a molecular formula C3H6O compound will form. And C3H6O, since double bond equivalent here is the 1, so either ये aldehyde होगा, either this will be aldehyde or this will be the ketone. But here this ketone will give, this compound will give negative tolerance test. So that means this is not the aldehyde. This is not the aldehyde. This is actually the ketone. Now this ketone reacts with the hydroxylamine and which forms an oxime, and this oxime having 19.17% nitrogen. So let's see this further. We will calculate. And now 2 moles of ester. Again question start. 2 moles of ester C. 2 moles of ester C. So this 2 moles of ester C, okay, when react with the C2H5ONA, just like Claisen ester condensation type reaction, so here beta keto ester will form. Beta keto, extended form of the aldol you can say, and here will form beta keto ester G. And alcohol B will also form. Okay, now this beta keto ester when hydrolyzed, this will form the beta keto acid. Okay, no problem. Ester will hydrolyze, then beta keto acid will form. And beta keto acid when heated, when this will heated, okay, when this will heated, then CO2 will release and CO2 will release, so compound E will form. Now let's start again this from G. If the compound is G compound is what? G is where? This is beta keto ester. Okay, uh, G is the beta keto ester. And beta keto ester when react with the RCl, then gives the I. R is what? I don't know. But let's see. And I when reacts with H3O plus, then K will form, and K when heated, then release the CO2 and final compound will form the 4-methyl pentane 2-one. Okay. So now let's here start from the 4-methyl pentane 2-one. Okay. So this compound is the, so first you will think that what should be the K, and K I think this is the beta keto acid. Okay, this is the beta keto acid. So here K will formed this and this, and here this and this here COOH. Okay, here R, what will be the R? We let's see. Another type of the beta keto acid may also possible, but let's see further. So K, I when hydrolyze. So what should be the I? I when hydrolyze. That means this, that is the ester. So C double bond O and this and C double O or O C2H5. So this is actually the I. Okay. And G reacts with ETONA. So G reacts. So what should be the G? So G, this is C double bond O and C double bond O and this. Okay, and when this will react with the ETONA, once a minute. When this react with the ETONA, then ETO minus, this will take hydrogen because this is highly acidic hydrogen, and acidic hydrogen, so this and this. Okay, here negative charge will formed, and this will attack on the RCl. And what is the RCl? What is the RCl? So let's decide. So what is the RCl? Okay, so here this should be actually RCl. So here negative I substitution reaction will take place, and this C double bond O, and here is the R, and here you can take R is equal to isopropyl group. Okay, so R is here the CH3CH3Cl. So let's assume for a very short time, let's clear this with other reactions also. Now come to the G. Okay, so you will have already cleared the G, beta keto ester, and now 2 moles of ester and C. So C is the 2 moles of ester. So what will be the here C? So here C. Let's see. We will see. So here C double bond O, or O and this. This is actually the C. And 2 moles of ester. Okay, 2 moles of ester. So here C, 2 moles of ester, and C2H5ONA. Okay, so C2H5ONA. So here Claisen ester condensation will formed. And what is the Claisen ester condensation? You know very well that here first of all this negative charge will formed, and this negative COO, and this negative will attack here. Okay, so here C double bond O, or O and this, and here once a minute, CO minus, and this O, and this, है ना? And here is the double bond O, and this, and now this O minus, this is a leaving group is present. So here C double bond O, or C double bond O, and this leaving group will remove from here, and this, and C double bond O and O. Okay, so this is also known as the beta keto ester. So our one of the compound will matches from here. So here this is the this will G compound will match from here. So 2 moles of ester, react with the C2H5ONA, form beta keto ester G. So this is actually the G. Okay, and alcohol. So this will formed here. So CH3 CH2O minus. So here from H2O this will take H plus, and CH3 CH2OH alcohol. So this alcohol will formed. So this is actually the B. So this is actually the B. Okay, so this G and this B, and now we will match this B. B is this alcohol anyway. Here now come to the B. So B is the alcohol which will oxidize. So B will the C2H5OH, and this will oxidize, and to form D. Okay, this will oxidize and to form D. So here is the CH3COOH, and this will D. Okay, and now when D reacts with calcium hydroxide, okay, so D reacts with calcium hydroxide. So here compound will form CH3COO ka whole twice Ca, which on heat and release the calcium carbonate and CH3COCH3. You already very well known that is the dry distillation of sodium salt. Let's see the explain the Reaction of this CH3 COO minus, CH3 COO minus, and Ca double plus. And when you will heat it, this type of compound, this salt will be heated. So here calcium carbonate will remove, and here acetone will form, and this acetone will formed. So what is the name of this compound? C3H6O. So this is actually the E, C3H6O. Okay. Now E will when react with the NH2OH, and simultaneously this give negative tolerance, sorry, negative Fehling. So it means aldehydes should not be present. So this is also the verification test. Fehling test negative. Okay. Now here E, you will take the E, and this when react with the NH2OH, this is actually the hydroxylamine, and E is what? Double bond O. So here minus H2O, and here oxime will form. So double bond NOH, and this is actually the oxime. Okay. And this oxime, and here in this oxime percentage of nitrogen will also be 19.17. So percentage of nitrogen, let's calculate percentage of nitrogen. So nitrogen here is the 14 into 100. For the percentage, 100 divided by total molecular mass. So total molecular mass, 12 36 carbon, and simultaneously 3 and 1 hydrogen, this 7, and 14 nitrogen and 16 oxygen. So 6 4 10 7. So this is actually the 73. So here we will divide this 73, and here 19.17% nitrogen. So this test will also follow the same thing. Okay. So now E will also have cleared what is the E actually. Okay. Now E. Now ester C and acid D. Now ester C and acid D. Okay. So now ester C and acid D. So ester C, okay, and acid D. Ester C and acid D formed when A reacts with the alcohol B. So A is any carboxylic acid derivative, just like the anhydride. So A is here the CH3COO, this C double bond O, and this is actually A. And when it reacts with the alcohol B, and what is the alcohol B? Acid D, acid B के alcohol के oxidation. Acid D is prepared by the oxidation of alcohol. तो अल्कोहल और अल्कोहल के ऑक्सीडेशन से अल्कोहल इज द बी, alcohol is the B. So acid B is prepared, and acid D, what is the acid D? Acid D is the CH3COOH. Okay. So acid D is CH3COOH, acid D, and this is prepared by the oxidation of B. So what can be this compound? CH3CH2OH. So when you will oxidize this alcohol B, so form the compound D. So form the compound D. Okay. B already you have cleared. B and D. And with the B and D, by the combination of B and D, a ester will form. So by the combination of B, so that means B and D. So CH3CH2OH. And what is the D? D is the CH3COOH. So here CH3COOH, and here will formed. So this compound, so this is B and this is D, and here CH3COO C2H5, O C2H5. Okay. C2H5. So this is actually the ester, and this is the ester. So here is this is actually the C. Okay. And now when A reacts with alcohol B, and now when A A reacts with alcohol B, C and this OH. So formed here C, this is the ester. This is the ester, and acid D, and acid D. Okay, and acid D. So what is actually the C? So here, and this is actually what? B. So here reacts with the, so this we will take the anhydride, and simultaneously this will react with the here OH. So when you will react this, actually this compound on this way. So here O minus, and when O minus will come, CO minus this and this. Okay, and here OH, C and C, and here is the positive charge will form, and O minus when this will O minus. Okay, once a minute. A when react with the B, so this will form the C. So this will form the, oh sorry, this is actually the anhydride. Anhydride. So here this is actually the leaving group. So when it is the leaving group, so C double bond O, and this, and here is the O, OH, positive this and this, and simultaneously CH3C double O minus, and this CH3C double O minus will take this H plus, so CH3C double O C plus CH3C double O H. So this is actually the ester, and this is actually ester C, and this is actually the acid D, acid D. And when again see, when this ester will hydrolyze, then CH3C double O H and CCOH will form. This is actually the B, and this is actually the D. And B when oxidized, then same acid will form. So we will take all the decision A, B, C, D, E, and F, G, H, I, J, K. So in this way, this question is completed. Thank you.